solutions also focus on smart cities. So for the first session, we will have Mágui Lage from EDPNU as our keynote, and we will have 3 very interesting Ubiwhere projects for the following order: Amber, Smart 5 Grid, and RIOT-ES. And on the second panel, we will have Ricardo Vitorino from Ubiwhere, who also happens to be the co-chair at AIoTI Working Group of Buildings and Communities. And we will also have 3 different projects: POCITYF, Poser, and CityCatalyst. So without further ado, we will now start with our first keynote, Mágui Lage from EDPNU. Mágui, the floor is yours.
Hello, Anna. Thank you for the introduction. I will share my screen. Can you see it? Can you see the presentation?
Yes, go ahead, Mágui. Thank you so much.
Okay, thank you, Anna. Okay, so so my name is Mágui Lage, like Anna said, I'm from EDPNU. And I will make a presentation on smart energy and smart cities with a special focus on energy communities. So just a quick definition of the concept according to the European Commission. So a smart city is a place that integrates physical, digital, and human systems and traditional networks with the goal of having a better use of the energy resources and reducing the emissions, so decarbonization. And this will lead to benefits in the citizen and business. But a smart city is not only about having smart devices or smart technologies. It is a broader concept, and I would like to have special focus on the integration of renewable energy sources in this environment. So we can think about having this integration of renewable energy sources, for example, through the installation of PV panels in the houses. This is something that it's really common during these days because of the low price of the materials and the systems. And actually, at this moment, the prices are so low that everyone that has a house of their own that is not installing PV panels is actually losing money, because it brings a lot of savings and it's really beneficial also in terms of the finances. And we can think about this integration in different ways, but for example, through the individual self-consumption and the collective self-consumption. When we have this kind of systems in our houses, a few years ago, we installed the PV panels with the goal of injecting the electricity in the grid, because the price that we will receive by injecting this electricity was interesting, but that's not the case anymore. So now what's more interesting from a financial point of view, it's actually performing the self-consumption. The self-consumption is nothing more than actually consuming the electricity that we are producing. So the individual self-consumption scheme, it's actually when we have different houses or industry or businesses, and we have a system, a PV system, and we prioritize the consumption of the electricity that we are producing. But we also have the possibility of injecting in the grid the surplus. When we have a collective self-consumption scheme, we have, for example, a PV plant, like we can see here. I will put the laser. Here we can see a PV plant, and we can share this electricity among houses or industry or another type of clients. And here we can talk about the concept of sharing coefficient. That is something that I will talk later on. We also have the possibility of establishing energy communities, and actually the collective self-consumption in energy communities is something that is really similar. It's only different in the point that in the energy community we need to have a legal entity to manage the community, but both situations have a focus on providing environmental, economical, and social benefits to the members in these communities. And so energy community can be anyone, so from a person to a business, private or public. The requirements to establish these energy communities is to be near the production sites, so the self-consumption production unit, and it must be owned by the members or the energy community itself. So as I said, the aim of an energy community is to bring environmental, economic, and social benefits to the members, and it also has the ability to produce, consume, store, buy, or sell the renewable energy. So the members can share the electricity between them. They also can inject in the grid. They can purchase from the grid, and so they have access to all energy markets. Here I can show you a simulation. So in the horizontal axis, we have the different buildings. In this particular picture, we have 33 buildings. In the vertical axis, we have the annual costs of the electricity for these different buildings or different houses. For example, the first house here has an electricity bill at the annual basis of 350. But for example, the house number 8 has a value of 550. When we do individual self-consumption, when these houses have PV panels and they consume the electricity directly for the house, we see that there is a huge drop in these electricity values, so the electricity prices. But this also happens, and it happens even more when we establish an energy community. And this is explained because of the situation in Portugal in nowadays. When we have excess or surplus of electricity, we have also the option of injecting in the grid. But at the moment, the price that we receive for injecting this surplus is not really interesting. So it might be a more interesting option to establish an energy community. And I can explain this by looking at this picture. So when we have different buildings, like the one showed here, so we have a building with different devices and different users, we can purchase electricity from the grid, that is here called SPE. It's the price that we pay for so taking the electricity off the electricity grid directly to the house. We can also inject in the grid, so the fed into grid electricity. We have our solar panels and the batteries, and we can also share the electricity among other members inside the community. If we see that this example, that is actually a realistic example in the situation of Portugal nowadays, we pay around 20 cents per kilowatt hour to purchase electricity from the grid. However, we just receive around 3 cents for every unit of electricity that we inject in the grid. And so we don't receive much by injecting the surplus. So if we establish an energy community, and when we do this, we have the possibility of defining the price that we want inside the members. It's really easy to have an interesting situation where we can pay, so the producer receives this value and the consumer pays this value, because there is a huge gap between these two values. So if I'm a member in a community and I receive, for example, 12 cents to sell the electricity to another member, this is more than I would receive by injected in the grid, and this is also less than the other member would pay to purchase from the grid this amount of electricity. So in our current situation in the country, it's really interesting to establishing energy communities. And that is why in this picture, the third line is below the other two, the line that is corresponding to the energy community situation, because we can have even more savings if we are inside an energy community. Here we can see a simulation that it's from a house, a family, that has a certain consumption, like we can see here in the blue line. And even if we have an undersized PV system, and here we can see in the yellow line the production, there is this moment in time where we can have an excess, and this excess can be better used by sharing to or selling to a member inside the community than actually injected in the grid. And this happens even more if we have an oversized PV system. So if we have a PV system that it's actually producing a lot more than what we need, then we have even more possibilities for selling it inside the community. Of course, that the goal of the community is not making a huge profit out of it, because if all the members want to make a profit by establishing an energy community, then it will not work, because all of them will have access, right? And if the energy community have an access, then they will end up selling it to the grid and receiving a low amount. But it's interesting to see from a different point of view that, for example, it's also possible for members that don't actually have a PV to be inside the energy community. And if, on the other hand, we have members that have a lot of surplus, so a lot of moments in time where they have an excess, it's interesting to see this type of dynamics. I will talk a little bit as well about the POCITYF project. Actually, Ubiwhere is one of our partners. We are the coordination of the coordinators of POCITYF project. And the goal of this European project is to transform historical cities into smart cities. And it comes with a lot of challenges. In this project, we have 2 lighthouse cities. So one in Évora here in Portugal and another one in Alkmaar in the Netherlands. And we have 6 different cities that are replicating what we are doing in these 2 main cities. And we also have the role of site managing the Évora site. So this is a picture of Évora, and we have 3 different regions, because our goal is also to reach energy positivity in these regions. So it means that we want to have more production than the consumption that we have. The 3 different regions that we have, it's the city center, the historical center. We have Valverde, that it's the rural area. And we also have industrial park. And we have different solutions that are being implemented in these 3 different paths. But actually, one of our goals is actually to establish an energy community in each one of these 3 different regions, so that we can also test platforms and tools and to reach energy positivity as the ultimate goal. I will show you 2 platforms that we are using. So one that is being developed by EDP and another one that is being developed by a partner of the project. So the first one is the Renewable Energy Communities platform. And as I said, when we are establishing an energy community, we need to have a legal entity that is in charge of managing the community. So the members that want to join the community, the members that want to leave the community, also the electricity bills. And I talked a little bit before about the concept of sharing coefficients, because we can also have the situation in which we have a PV plant and then we have the users inside the community. And at this moment, the Portuguese legislation foresees this division of the electricity in 2 different ways. So we can divide the electricity production of this PV plant among the members in an equal way. So we have a PV plant and we have, for example, 10 houses, and each one of these 10 houses receive the same. And so this is the coefficient. It's the same coefficient for everyone. And we also have the option of having a coefficient that is proportional to the energy needs of these houses. But actually, none of these 2 options are really fair, because for instance, in the first option of receiving exactly the same, this is not adjusted to the needs of each house. But on the other hand, in the second option, if you receive more electricity because you also consume more, this is also not really fair, because one can say that it's making a huge effort to have a more efficient house, and so the consumption decreases. And at the same time, it's receiving less because the consumption and the need is not that high. And so with this platform, we are also going to try to test what it's called a dynamic coefficient, that it's based on a PhD thesis of someone that is also working in this project in EDP New. And so this is something that really can change the situation that is happening now. Another tool that we have, it's the peer-to-peer energy trading platform that actually allows the members to exchange electricity among them. So they can choose the person that they want to sell electricity to. They can buy electricity inside the community, and also they can donate electricity to a certain institution or organization. And this can also help fighting the energy poverty, that it's something that we are constantly hearing about, that it's a project, that it's a problem of these days. And so these different tools inside the project, I think they will help develop this concept of the energy community, and hopefully serve as an example to the future and for the country. At the moment, we are still in the process of being able to establishing energy communities, because at the moment we don't have official energy communities in the country, and so we are taking advantage of the fact that we are doing this project and that we have an authorization to implement energy communities in Évora, to try to help and accelerate all of this process. And so, just to sum up, this is a quote from the European Commission. Energy communities make it easier for their citizens and other market players to team up and jointly invest in energy assets. This in turn helps contribute to a more decarbonized and flexible energy system, as the energy communities can act as one entity and access all suitable energy markets on a level playing field with other market actors. Energy communities can be really important also because it decreases the dependency that people has in the electricity grid. And so this empowers the citizen to have control in their electricity production and consumption. Thank you a lot for your attention. I'm open to any questions that you might have.
Thank you, Mágui, for your presentation. So just for everyone to understand why exactly Mágui is here and why she's an expert in this field. So after studying mechanical engineering at University of Lisbon, Mágui chose to specialize in the field of renewable energy, focusing on the development of the role of energy communities in energy transition. So she has been working with EDP in projects that focus on energy communities and their influence on policies for solar energy for quite some time. And today we all understood exactly how much she knows about energy communities, which she tried to explain so well to all of us. So I do indeed have some questions to try to help our viewers and all of us understand a bit more of this topic. So my first question is, what are some of the most promising emerging technologies in the energy sector, to your knowledge?
Thank you, Anna. Thank you. Okay, so I would say that one of the main promising technologies, from my point of view, is actually the building integrated photovoltaics. That is something that we are trying to implement in Évora in this project, because most of the cities that we have in Europe are historical cities, and these cities have to face a lot of challenges when it comes to the heritage. And so the building integrated PV, it's something that enables to have production at the same time that we are protecting the cultural heritage. So, for example, PV glass instead of PV panels, PV shingles. This hopefully all of those technologies will be implemented in Évora until the end of the year. And so I invite you all to go to Évora to see the technologies that I think are one of the most promising technologies in the energy sector.
Thank you. And as you were saying, all of these are being implemented through the POCITYF project. Is that correct?
Yeah, exactly. So we have a lot of historical buildings in the project, and because we had to take care of the buildings to be able to keep the heritage, we looked for solutions that can also be implementing in the scope of the smart cities and the energy sector, but at the same time keeping the aesthetical appearances of the buildings.
Okay, thank you. So my next question is what do you think will be the biggest challenges facing the energy industry in the next decade? And how are you at EDPNU and within your projects working to adapt and to prevent and to address them?
Yes, so one of the biggest challenge in my point of view is the energy dependency that we have in other countries, and we have talked a lot about this in the past month because of the war that happened between Russia and Ukraine, and we need to be self-sufficient in terms of energy, and so I think this is something that can be addressed by the renewables and by energy communities, like I said, because establishing energy communities and having this type of technologies, it's something that also gives the power to the citizen and make them less dependent on the energy grid. On the other hand, I think a problem that we will also have in the future, it's the shortage of raw material, because all the technologies that we have rely on resources, natural resources, that might be in shortage in a few years from now. Mainly the silicon or the lithium for the PV panels or batteries. And also the net congestion is something that it's a topic that we should be worried about, because as we have more decentralized production, we will have more injection in the grid. And at the moment, our grids are not prepared for that, because they were built a lot of years ago in a different model that we have today. We used to have a centralized production through the thermal plants, and now that we have more renewables and with the decentralization of the energy production, we need to adapt and we need to have new grids and smart grids.
So you mentioned through your presentation that you have a special, I would assume, authorization to create energy communities in Évora. Do you think that after that experience and how it is going, we will have that authorization to have energy communities all over the country? Or do you think that's something quite difficult to achieve in the near future?
So what we had was an approval of RIOT-ES, so the energy entity. And now we are trying to make an application to the GEAG, so the energy and geology entity. And our goal is with the project to show that actually we have a lot of benefits establishing the energy communities, and that this could kick off the implementation of energy communities around the country. Because I think that will be the future, to have energy communities all over the world, actually. So it may serve as an example to show that it works and that actually the members have a lot of benefits with it.
So I'm assuming the results must be very good.
I hope so.
Okay. So my next question is, how can we ensure that energy solutions are accessible to all communities, not energy communities, but world communities, including those in developing countries or with limited infrastructure?
Yeah. So in developing countries, the main issue is the money, so the financial aspect. And I think that one of the solutions could be having second-hand devices, for example. One thing that we are also trying to implement in Évora is second life batteries, because at the moment storage is really expensive. Actually, if we do the calculations, we see that if we just install a PV panel in the house, a PV system, we can have a payback period of around 4 years. So if it has a 20 years lifetime, a lifetime of 20 years, we ended up making money through the rest of the 16 years. But if we put in the equation the price of the batteries and the fact that they last approximately for half the period of the PV, then we don't receive any money at all after the 20 years. So it's not a really viable situation. And with the emerging of the electric cars, electric vehicles, we notice that the batteries that we have in the cars, when they stop being useful in terms of cars, because we have a lot of cycles when we use electric cars, we actually can use those batteries in stationary environments. So for example, the storage in the house. And the second life batteries that we are going to install in Valverde in Évora are actually batteries that used to be electric vehicles batteries. And this can be an option as well, also through the recycling of the materials and the PV panels. This can lower the prices and allow developing countries to also have access to these kind of devices.
Okay, thank you. So I will move to, I hope, what is my last question, and I invite my colleagues that will present some projects after this keynote to ask any questions if I have them right after you answer my last one. So I think it's the most complex question, but I'm gonna ask it anyway. So what are some examples of successful energy solutions that have been implemented in smart cities around the world, to your knowledge, obviously?
Mm-hmm.
And how have these smart technologies played a role in their success?
Yes, I have to say that this is the most difficult question of all. But if I had to say one, I would say the smart grids. Like I said, in Portugal, our grids are old grids. Let's say they are not adapted to the new systems and the new devices and to the decentralization of the energy production. And I would say that having smart grids that could include storage systems so that the independency could be increased, I think it would be a really nice energy solution, because with a smart grid, we can also have, for example, self-healing systems. So the maintenance of these grids would not be that the same that it's now, and including ICT systems, so communication systems, so that everything could be connected inside the smart grid, and so a smart city. So that would be my bet.
And are you already working with smart grids, either in Portugal or in any international project?
I'm not inside any other project, but we have a team inside EDPNU that is specialized in these types of solutions and projects, the smart grids and services.
Well, we as well are trying to work in that topic, and one of our presentations today will focus in one of our smart grids with 5G technology. So thank you, Mágui. I don't know if any of my colleagues wants to ask a question, but if not, I want to thank you for being here today and to present all of these and answer all of these questions that I along with my colleagues prepared for this event. Thank you so much. And now I think we can move on to our first speaker of our first project. Inês, I think you can.
Thank you, Anna.
Thank you so much, Mágui.
Hi, Anna. Good morning.
Hi, good morning. So Inês will present one of our projects. I'm gonna share the screen. Please let me know as soon as you are watching the presentation.
Yeah, it's working.
Perfect. So go ahead, Inês.
Hi, everyone. I'm Inês from Ubiwhere, and today I will present you the Ember solution. Resuming this project in some words, the main goal is to allow the scalability of electric mobility infrastructure throughout interoperability. So let's go straight to the point. According to the World Economic Forum, mobility is fundamental. However, the current reality is not sustainable. That is why in the European Union, The target is to align transport taxation and policies towards decreasing the greenhouse gas emissions and increasing the adoption of electric vehicles. Current policies have led to a rapid growth of electric vehicles, which requires a flexible and modern charging infrastructure, avoiding vendor lock-in. Without addressing interoperability issues, charging infrastructure will continue to scale along fragmented and inefficient paths, potentially resulting in higher costs, less than optimum customer experience, or even stranded investments. Just to make sure that we are aligned, interoperability can ensure the communication between the physical and digital world, as well the communication between the different systems. Well, our solution has the ambition to change this reality, so let's meet Amber. Amber allows the scalability of mobility infrastructure throughout interoperability by implementing SAREF ontology on our EV charging management platform. Throughout the interconnect semantic interoperability framework, the interconnect is a project that aims to develop interoperable solutions to connect smart homes, buildings, or grids. And Amber solution will be a gamified mobile app for drivers to unlock chargers and initiate the charging process and consult their own historical and real-time charging operations. Besides that, we will have also a web dashboard that will allow the EV chargers owner to manage the users, the vehicles, view performance KPIs and analytics regarding or related with the energy consumption, for example. Our EV charger management platform, as you can see in this image, it is a platform compliant with the international standards that allows EV chargers owners to manage the network while enabling drivers to manage the charging process. So I have here two images. In the one on the right side, you can see how the user is able to see and to check the state of the charging process. So if the charging process is ongoing, it will show a charging status. If it is completed, it will show the complete status. And on the left side, we can see also how the user can ask for a charging process for his own car. So the process will be to choose the EV charger. As you can see right now, he is choosing the EV chargers by scanning a QR code. Then you will select the car that you want to charge, the power that you want to charge, and the pickup time that you want that he needs. And then the process for charging the EV will start. But why is this solution unique? We have 5 main reasons for to think that this solution is unique. So the first one is that by investing in semantic interoperability, we are looking at the large-scale scenarios that comply with the European Union directives and objectives regarding the sustainable and green mobility. To implement such scenarios, public and private entities must invest in EV charging infrastructure. So the goal here is to prevent these entities from becoming dependent on EV chargers providers and allow the scaling up of the network to include assets with different capabilities and communication protocols, improving the service that are offered to the EV drivers. Also, can you go to, yeah, thank you, Anna. Also by providing an integrated solution that allows the analysis of the user behavior and infrastructure management, it becomes possible to provide data including vehicle type and other specificities like charging period or energy consumption. And this consists of relevant insight that will allow infrastructure owners to optimize the network efficiency and improve planning capabilities for the network extension. Now you can, thank you. Also, the designed and implemented the fact that this is designed and implemented in a modular way, the solution architecture make it possible to quickly and easily integrate new equipments, data sets, or features. And in this sense, the platform is prepared for a cross-domain implementation, allowing like holistic analysis for the EV charging sector by correlating it with data from different domains like energy or mobility. Including also gamification features allow us to reward citizens for opting for sustainable mobility options, and also semantic interoperability is expected to facilitate this mechanism and this reward mechanism and drivers' engagement. The last point is that the solution will go behind existing ones by allowing citizens to get detailed information about also their carbon footprint in a dashboard that was built on the best principles of UI/UX. Ubiwhere ambition for this project will be also to validate this solution in real-time scenarios. So in this project, during the Amber project, we aim to validate the solutions in a Portuguese pilot by demonstrating that the system works on private areas that can promote and that can promote iMobility. We are going to test this system in different cars from in Sonai with different models and brands of cars and different communication protocols to validate that our system is interoperable. The opportunity to validate Amber solution in a Portuguese pilot will give us also a crucial insight of the national users' preferences. So you can go. Thank you. Just to end, let's go for it and help Ubiwhere to optimize and scale EV charging business and transform the current iMobility paradigm towards the sustainable choice. If you have any question, please let me know, and thank you.
Thank you, Inês, for your presentation. I think I'm going to ask a quick question. So regarding the pilot, do you have plans for when it is starting?
Yeah, so we are now working in our mobile app. We are thinking to end this mobile app on June, and we are going to start our pilots on July of this year. And we are thinking about some EV drivers to test, so we are trying to collect a lot of data to validate the project.
That leads to my second question. What do you think will be the biggest challenges in having people accept to be part of the pilot?
I think we are already facing those problems. So I think that the best or the biggest problem is to get users, EV drivers to try our system. Right now in Portugal, we don't have a lot of EV drivers, or if we have, they have their own systems. But here the main goal is to, so imagine that you want to charge your car while you are working. So you go to your work and you charge your car in your company, and then you go home and you don't need to charge your car. This is the main goal, but our main difficulty is to have these EV drivers to try the system.
Thank you so much, Inês. I don't know if anyone else has any questions, but if you do, I urge you to contact us, and obviously we will put you in contact with Inês, who is more than capable of answering all of your questions. So thank you so much, and I think we can move on to our next speaker, who will now present a project with one of the topics that were already mentioned here today. So Hélio, I invite you to present and show us your face exactly. So we will now hear a bit about what are smart grids, which we already heard during our first presentation with Mágui. So Hélio, I think we're all a bit excited to know what exactly are smart grids in more detail and what we are working on with smart grids. So the floor is yours. Go ahead.
Yes, thank you, Anna. And indeed, I mean, when I was listening to our colleague from ADP, Mágui, I mean, she already introduced a lot of the stuff that we're going to touch on this presentation. Anyway, without further ado, so I'm Hélio, product owner at Ubiwhere, and I'm going to showcase how some of the solutions that we are developing can help and who to overcome these challenges of making the grids smarter, so to speak. So a bit of context, and I mean, Mágui did this brilliantly. So basically, this is what or how or energy grids currently look like. So in the sense that the energy is generated in, let's say, a large central plant, and it flows. So that, let's say, in the downstream until it reaches our homes, and make it possible for us to be speaking here in a complete remote scenario. This is what, and briefly touching on what Mágui said. So this is the dream, let's say, of the smart grid. So we can see that it's a way more distributed manner. We have a lot more, let's say, sources of production of electricity, and of course the main focus here being, for example, the smart houses, solar power plants, and so on. Also smart buildings that can be maybe not self-sufficient or at 100%, but at least have the capability to produce a lot of the energy that they need to operate, let's say. So having this in mind, this brings, of course, a lot of challenges, right? So again, the variability and unpredictability of the, let's say, the more green energy. From one side, we need this, but on the other hand, this makes very hard because, for example, when we need more energy, especially during winter time, and for example at night, might not have, or we most likely, or we don't have sun, we might not have wind. So this is the challenges that, let's say, the reality punch in the face, so to speak, that okay, in theory we can all just go to green electricity, but then okay, we need to solve these problems as well. Of course, storage being one of the main, or let's say, a possible solution. Anyway, this brings us to the second bullet, which is the stability of the power grid. So it, in a sense, and Mágui explained that very well with that graph, where there's periods where we have way much more production than we have consumption, and vice versa, right? So this needs to be adapted. Of course, especially in the developed countries. So one thing is, for example, and it was already touched upon. So an emerging country, so or an underdeveloped country, in one end, and of course with all of the financial issues that were already described. but they do have an advantage when compared with developed countries, which is they don't have all this old junk, so to speak, which we do, which is the old grid. So they can actually start with, let's say, the state of the art, and in that way, as long as they get the financing, they do start a little bit ahead, because they don't have to retrofit or integrate all these legacy equipment. So in that sense, it's actually easier, let's say. But for us, of course, so we have all this legacy equipment that we need to, and the way that the grids are architectured and so on needs to be taken in consideration, so that we don't go from 0 to 1. We need to there's a path that we need to undertake to reach from a normal grid, let's say, or the current grid, to a smart grid. And of course, the last but not the least, even before the Russian attack on Ukraine, a lot of critical infrastructure was already being targeted by cyber attacks, whether being hospitals, the energy grids, and so on. So this is just an example of how, okay, it's very good that now we have smarter grids, but we just open ourselves for a new attack surface that we need to of course, be mindful of. So these are some of the challenges, and in essence, the question that I'll try to answer here is how can we go from the current state of energy grids to smart grids? How can Ubiwhere help with that? So in a sense, I'm briefly presenting what we are doing in Smart 5 Grid project. Basically, we are providing a platform that will serve several purposes. Some of them are listed here. For example, the management of networks, and this so even though that, okay, we have an energy grid, it's a network on itself, electricity network, but we do need kind of an oversight network, and this is where we come in. So a lot of projects and a lot of solutions are being developed, a lot of innovation in this area which is using 5G. The technology is there. Some of the challenges are more on the economic front, where the cost of the devices, the cost of the gateways is still a bit high when compared to Tetra and other technologies that are currently being used. But of course, with time and with scale, the price will drop, because technically speaking, the possibilities are there, and telecom system ecosystem itself is undergoing several changes that will facilitate, let's say, the deployment of these new solutions. Of course, security being one of the primary concerns as well. From we are partnering in this project with the University of Coimbra, and they are helping us, and they are bringing this framework for security and protection. And of course, this is a very generic bullet, but it's so the monitoring of smart grid infrastructure. So this goes from devices through the network itself. So it covers a lot of ground, but it's something that for sure it's a must if you want to be able to control and to manage at the scale of at the national scale that the energy grids have. So who is this targeted to? So energy companies like DSOs and TSOs, like on the schema that we previously did, and OEM service providers. So basically, we are trying to help through technology the modernization of this sector. And so some of the products, because software is very reusable, and we do appreciate it. So a lot of the stuff that we are cooking, it can be applied not only to the energy sector but to other sectors, or maybe some of you already heard being referred to as verticals, the different sectors of the economy. So like manufacturing. So in essence, an IoT platform is something that we are developing, or a product we are developing to make sure we can have supervision, control, and management of devices, being a grid device, being a factory floor device, or hospitals and so on. Also, this all, and data, it's the new oil, right? So all of this and all of these devices that are censoring and sensing, let's say, the environment or the infrastructure, bring data, right? And so data is vital. So we need to make sure that we can collect, we can treat and clean the data, and it's then it can be used for visualization and sell a story. And in this way, we also open the door for it's not the ChatGPT, but all the AI and machine learning models that with huge volumes of data can tell us stories that otherwise without these tools we couldn't really know about these stories, let's say, and how the data can inform us and make us take better decisions. The urban platform, this is already a very mature product that it's live in several municipalities. That it's very strategic to integrate what currently we are doing with the municipalities, also to the vertical energy, the vertical the energy vertical. Sorry. So in this sense, we are tailoring or shifting a little bit of what is our main area of business, which is smart cities, or within the smart city, but more into the energy domain. Of course, this again, we need to monitor and all the information. So pretty much what it's on the IoT platform, second bullet. In this case, it can be done via an IoT platform or through existing platforms such as our urban platform or DSO, TSO platform that I already use. So this is a very modular, and it's a good thing about software, how you can produce something in the back that will fit a dashboard, whatever that, for example, one of the energy companies already have. So we are completely interoperable in that way. So these are the two main products that we highlight, and we are, let's say, incrementing in Smart Hybrid. Anyway, you've been hearing me to talk for, I don't know, about 10 minutes now, but tell me, where do I use it? How can I use it? Fair enough. So these are some scenarios that we envision and from the research that we did. So of course, I'm talking about managing the network and devices and so on. So this is of course a scenario one. This is something that also running a lot of, let's say, more a service-based architecture. This is very cloudy terms. So we can try and bring what the cloud has good, what the good has the cloud to offer, and we can try to implement to these in a more, let's say, smaller scale, but it can be useful to check a lot of incidents and managing all the services that are running, and then make sure that the network keeps running. Of course, data again. So this is all vital nowadays. So like I said before, we need to make sure that the data is available, the data is treated, the data is correct, so that we make sure that what we are seeing from the field actually is truthful. So all of these are concerns that we do take in consideration. Of course, who is managing the network? I mean, the more complex these systems become, we do need to make sure that, and with the shortage of talent that there is in all areas, we might not have, let's say, super experts managing or monitoring the network. So there's a good value proposition that these platforms can offer in terms of helping who's monitoring these very complex systems, and in this case the grids as well, with smart alarms, with a lot of routines that otherwise would be being done by a human, but that the machine can already, let's say, pre-troubleshoot some issues, and then when it comes to the person who is oversighting things already, it needs to take a decision, or there was already a lot of stuff that was done in the backlines. Cyber attacks, of course. So like I said, when we are modernizing something, when we are making sure that everything is connected, and we need to be mindful that we are exposing critical infrastructure to cyber attacks. So this is something that it's just we have to live in. Here in Portugal, we had Vodafone, we had Expresso, or the media company that was attacked, and this will most likely repeat because it is what it is, right? It's the other side of the same coin of these more modern systems, and of course, if a cyber attack occurs, the good thing that what we can actually use it. For example, AI is already being used in this way to already either first identify, then take countermeasures. So this is something that we can even take preventive measures. So this is all, let's say, very research topics, but that are very important and vital, so that these systems in the future are way more resilient. So this is it from us. I hope that you were able to learn a little bit more of what we are doing in this context. And Anna, I'm ready for your questions, so fire away.
Thank you, Hélio, for your presentation. Obviously, I have a question, and I don't know if any of our other colleagues that are presenting today have any other. So mine, I think it's simple. I think. So we heard Mágui saying that smart grids are solutions of the future. I would say something like that. So in your opinion, and being involved in not only this one, but in another smart grids solution and project in a European level, I wanted to ask you, what is your opinion regarding the timeline in which we will have smart grids, and in this case, smart 5 grids available for everyday life, I would say.
Yeah, I mean, it's a great question, and maybe you wanted an answer in form of a date, but I'm going to do some jiggling around. So first of all, of course, it will depend a lot of on other infrastructures, right? And in this case, I'm speaking, or I'm directing to telecommunication infrastructures. So this is something that, as we've seen, the more devices and like these are grids that expand through the length of an entire nation, right? And these are grids that are being done by decades. So and when we look at the overlapping of the energy grid and the telecommunication grid, if you want to say like this, we notice that a lot of places that luckily already have or have electricity, but might not have coverage, either in form of, and I'm speaking either fiber or from 2G to 5G or whatever other form of connectivity. So this is a main prerequisite, let's say, of having smarter grids, is to have more broader communications.
And do you think that's the biggest challenge, having both grids at the same place at the same time? Sorry for interrupting your answer.
No problem, and great question. I mean, it's something that it will. This is why, for example, heads or a lot of the energy verticals already have their own, let's say, private networks specialized for this, because critical infrastructure might not want to rely on public network for several reasons, right? This is, with 5G network slicing, this can change, but right now what we are seeing, and if it's this critical, you need to have your own kind of, you need to do it yourself. So having said this, like I said, the technology is there. There are some factors that will, let's say, delay or will cause, such as the cost of the equipment. Of course, there's still human skills that need to be acquired by all of these companies, in this, like heads and other companies that are using the grids, because they will be the ones operating this. So in this sense, I think that I don't know, maybe towards, and it depends on how fast the countries go. And of course, I think that with the smart grids, the good thing is that you can do this by chunks, so that, like I said, for example, an underdeveloped country doesn't need to create this whole system, like the developed countries had to undergo in the past. They can have maybe a smaller energy generation site, like a solar panel park, and then they can already feed, let's say, a smaller village. So this is already kind of a standalone, and then they just need to interconnect all of these different energy islands. Okay, so I didn't give you a date, but hopefully I shed some light in terms of some of the, let's say, factors that will count in terms of accelerating or be a catalyst or not for these smart grids.
Thank you so much, Hélio, for your help and for helping us understand smart grids, and in this case, smart 5 grids. So I think we can move to our last speaker of this panel, Eva.
Yes, Anna.
Thank you, Hélio. Yes, thank you. Can you share?
Yeah. Yes.
Thank you so much.
Can you see my screen?
Not yet. Just a moment, because I think, yes, now we can. So go ahead,
Okay.
Eva.
Thank you. I'm Eva from Ubiwhere, and I'm here presenting RIOT-ES in the Shaping the Future of Smart Energy and Smart Cities. So this consortium is composed by Ubiwhere, that is the project coordinator, from KAIST, that is the first top science and technology university based in South Korea, from POCITYF, that is a major player in engineering that is based in Portugal, and finally KULS, that is a major player in ICT, logistics, and construction based in South Korea. So low in energy efficiency in IoT systems poses as a challenge. That is why we decided to write the proposal that lead to the project. So with the increasing number of IoT devices and complex IoT applications, the IoT systems consume a significant amount of energy, which makes energy efficiency an important issue to address, and the number of efforts that have been done to optimize the energy consumption in IoT. However, the efforts done so far have focused on particular IoT applications dedicated to particular scenarios. So the low energy efficiency in IoT systems poses also as a challenge with the increasing number of IoT devices and complex IoT applications. So the low performance in IoT systems, generally IoT data are processed in the cloud through computing resources that are located in data centers and different geographical locations. This causes higher latency and increased network bandwidth. So issues regarding integration between the cloud and the IoT and the provisioning and resource management are currently open challenges for IoT systems making use of fog computing. So our value proposition and innovation in this project specifically, we intend to focus our effort around two aspects of IoT systems that are both dependable and complementary: energy efficiency and performance. So the project is nearly the end. We finished the project in late July. So one of the most important goals of our project is to investigate the problem of increasing energy efficiency in IoT and to bring in important contributions which are not dependent on the particular application and nor are dependent on the particular conditions. And additionally, the project aims to design and execute edge computing in its use cases in order to improve IoT performance. So Ubiwhere use case is the smart parking. In the images you can see the that is our headquarters, and we have the camera that will process image. The media acquired will be processed using image recognition software to allow the perception in real time of the status of each parking spot. So we intend to know which parking spots are available for a person to park. And the different AI algorithms with different computational costs are aimed to be used in the context of this use case to achieve the lowest possible energy consumption. Finally, the smart home use case that belongs to our Korean partners. So this use case will specify, implement, and demonstrate the usage of radar-based contactless biometric sensor in the living space of a single household. They monitor different persons and in their lively homes, and they extract metrics, of course, all this based with concerning the RGDP issues. We have that all covered. So that's it for me. Thank you very much.
Thank you, Eva. Obviously, I have one or two questions. So you mentioned that the goal of the project is to study the problem regarding increasing energy efficiency in IoT. The project is almost ending, correct?
Yes. Yes.
And do you think we will have at least some pointers as to how to solve this problem?
Yes. We did we have pilots on the way, so our Korean partners are almost ending their pilots as Ubiwhere's, and we have some metrics that were going to be very useful for this low energy efficiency to be applied in these use cases in particular.
So with that said, I believe that we can say that in cases such as the ones that are being studied, we will be able to lower the energy consumption and increase the energy efficiency.
Yes. Okay. That is our main goal, and we have I have certain that we are going to propose some solutions to that.
And do you think in the future, well, not exactly now because the project is ending, but in the future, we will be able to address other use cases with some of the things that we learned from these ones?
Yes, of course. This could be replied to another use cases. We have to, of course, see what are the basis of the different use cases, but yes, this software and the things we develop in here can be replied to another use cases.
Okay, thank you so much. I don't know if there are any other questions for our speakers of this first panel. If not, we will have a short break and then we will move forward for our second panel of the morning, focusing on smart cities with our expert from Ubiwhere, Ricardo Vitorino. So I will invite all of you to come back in about 20-25 minutes so that we can move forward for the next panel. Thank you, everyone, and I hope to see you in a moment.
problems. So in a nutshell, smart cities can be defined as these urban areas that leverage advanced technologies, data analytics, and connectivity to improve the efficiency, the sustainability, and quality of life for residents. Okay, these are the outcomes that we want to achieve. These cities typically use innovative solutions to address urban challenges, enhance infrastructure, and even optimize the resource management. We need to take into account two important qualities. Okay, the smart use technology. So when they use it as a primary tool, it helps the city become smarter, and therefore you see a smart city as a system of systems that optimizes resources for humans. And with the human perspective or the human-centric approach, we follow people first. So if we deploy the technology correctly, it should be almost invisible, or at least non-intrusive. Okay, so it really should matter the outcomes for people following this human-centric approach. Let me just change something here. Okay, and this smart city initiative is not something recent. In fact, it has been for quite a few time now. This screenshot shows the Google Trends snapshot, which is, well, Google Trends is a useful tool to understand the level of interest and popularity of certain topic across the web, and this showcases the smart cities worldwide interest over time, and it started from the Google perspective since 2000, and you see that you see this tendency of growing of interest, with more people searching for information and resources related to smart cities. So there's this growing awareness and curiosity about the topic. I don't know how to explain you the peak on 2015. By then, Ubiwhere had already a good popularity with CityBrain brand. I don't know if that was the correlate impact, but in parallel, for instance, the Google parent company, the Alphabet, was releasing its Sidewalk Labs announcement, which may have generated significant media coverage and public attention. So with their huge project and plans that at the time was for a Canadian city, as far as I recall, it sparked curiosity and increased searches related to the topic, and people have become more aware. But indeed, this concept beyond Google was, or Alphabet was already with a significant traction globally. So we were already seeing in the Smart City Expo World Congress in Barcelona, different governments, organizations, and urban planners recognizing the potential benefits of implementing these initiatives, such as smart parking, bike sharing, and waste collection optimization. And well, this growing awareness and adoption could have led to increased public interest in search queries for the topic. And as I mentioned with the Smart City Expo World Congress, other events and conferences have demonstrated this prominent interest from the community about smart cities. So they drive public interest, they drive discussions around the smart cities, which then lead to these spikes in search and further interest for research and implementation. And in fact, it's not just for the sake of curiosity. The smart cities are actually important for the more modern urban context. Regarding the improvement of quality of life, smart cities aim to enhance the well-being and quality of life of citizens using technologies like Internet of Things, artificial intelligence, and data-driven governance. Cities can provide better services, optimize transportation, improve healthcare, and enhance the public safety. The sustainable development of a city is properly mapped with the Sustainable Development Goals. They prioritize sustainability by integrating renewable energy sources, optimizing this resource consumption, and reducing the environmental impact of the different services and infrastructure. So these initiatives should contribute to mitigating the climate change, to improve air quality, and foster the sustainable growth, which not just has an impact on environment, but actually on economy and society. So this economic growth and innovation then allows cities to act as hubs for innovation and economic development. They attract technology companies, they foster entrepreneurship, they provide a supportive ecosystem, and they can then generate more job opportunities, promote economic growth of businesses and local services, and drive these technological advancements, which then improve the quality of life of people who then stay more in those regions. But in order to take this into account, the resources must be efficient. So they should optimize the use of research such as energy, water, transportation. And when they employ real-time data analysis and predictive modeling and some automation, they can reduce waste, they can improve energy efficiency, they can enhance urban planning and infrastructure management in a smart way. And as you might recall from the previous slides, cities are for citizens, and it should follow a citizen-centric approach. So by empowering citizens and encouraging their participation and engagement, either through digital platforms, mobile applications, or other participatory approaches, residents and visitors can actively contribute to these decision-making processes, offering feedback and collaborating with the city authorities, fostering a sense of ownership and inclusivity, which is essential for the resilience and disaster management, because the major concern is to protect not just the natural heritage, the cultural heritage, but actually the communities who live and work in the city area, so to protect human lives. And smart cities have been focusing on enhancing their resilience against natural disasters, emergencies, and other challenges. So by leveraging technologies like sensors, analytics, and early warning systems, they can improve the preparedness, response, and recovery, ultimately to save lives and minimize damage. But this has to take into account the people who live there, so that these systems are actually used and reach back to them. So as you know, smart cities has come a long way. So I wanted to provide a very brief overview of how things have been evolving along the time. And the early concepts and the technological advancements started in the late 20th century. So it was by then that the concept of smart cities first emerged in the research papers and research initiatives. They envisioned urban areas that use technology to improve the efficiency, sustainability, and quality of life. And then in the 90s, if you remember that time, there were some advances in ICT, so in information and communication technologies such as the internet and wireless communication. So it laid the groundwork for smart city development. Then in between late 90s and early 2000s, so in the initial beginning of the millennium, several pilot projects and initiatives began to explore the possibilities of smart cities. And one example back then was Barcelona's CityOS project, so City Operating System, which by then, in the early 2000s, it aimed to integrate already various systems and services using ICT to enhance this urban management and citizen engagement. So they already had a couple of applications collecting data and engaging the community and integrating it in a single place called the CityOS. So these pilots then led to further infrastructure and connectivity deployment. So still in the early 2000s, there was this focus on establishing the needed infrastructure and connectivity for large-scale smart city implementation. The community started to develop broadband networks, sensors, and data collection systems like IoT platforms and other tools to support these smart city functionalities. And in the mid-2000s to early 2010s, we saw a bigger focus on data-driven governance and sustainability. So there was this increasing emphasis on data-driven governance and sustainability in the smart city planning. And we started to see this integration of data analytics and real-time monitoring to optimize resource management, energy efficiency, and urban planning. And on the second half, there's a typo there, so 2 out of 2. We started to see then from the mid-2010s, the citizen engagement and participatory approach. There was this growing recognition of the importance of the engagement of the community in the Smart Cities initiative. So there's more and more digital platforms and mobile applications were used to involve the citizens in these processes and gather feedback for better urban planning. And from even the different presentations here today, you see that there's a lot of IoT data and artificial intelligence solutions. So these have advanced from the late 2010s. We saw a lot of development on Internet of Things, big data analytics, and even artificial intelligence, so the AI technology to further propel the smart city development. We've been integrating sensors, devices, and even AI algorithms to handle this real-time data analysis, perform predictive modeling, and automate some tools for efficient urban management. And more recently, so in the 2020s, which we are now still in the beginning of, we have been seeing this increasing focus on sustainability, resilience, climate change mitigation in the smart city strategy. So you see from the European Commission the Green Deal, you see from the United States also the new Green Deal. So you see a lot of high-level government initiatives. From the United Nations, we have the Sustainable Development Goals and a lot of propositions for circular economy, for sharing resources, reducing the environmental impact, and this allows for and is enabled actually from the integration of renewable energy sources, the smart grids as shared by Mágui and Hélio, the sustainable transportation systems that actually enhance the resilience of these communities and reduce the environmental impact so that we don't waste so much resources on these things. And from now and beyond, what we expect to see is these emerging technologies and this future outlook for the continued exploration and implementation of these technologies in smart cities, namely the 5G networks, blockchain and distributed ledger technology, autonomous vehicles, and smart infrastructure for this enhancement of connectivity, mobility, and urban experiences. So in order to make this a reality, there are a couple of key components for smart cities. So on the first layer, we need the infrastructure and connectivity. So smart cities actually require a robust infrastructure backbone. This includes high-speed broadband network, communication infrastructure, and IoT-enabled devices. So if there is no power or no communication technology, data cannot be exchanged between systems and places. And if something goes wrong, we need to rely on that. So this infrastructure must facilitate the seamless flow of data and enable integration of various systems and services and be resilient as it is. So connectivity plays a vital role in connecting people, devices, and the infrastructure to enhance the efficiency, to enable the real-time monitoring and support these innovative applications within the city. Then we have the data-driven governance, which involves collecting and analyzing data from various sources to inform the decision-making processes and authorities in the city. It should handle data collection, storage, analysis, and visualization to gain proper insights and make better informed policy decisions. By leveraging on these capabilities and even going further with machine learning and artificial intelligence, city administrators will be able to optimize the resource allocation, improve service delivery, respond proactively to emerging challenges from the growing population, from the climate changes, from pandemics, as we've recently saw affecting all of us in the world. As a proper focus in this last couple of years, we are mostly seeing sustainability and energy efficiency as a priority. So prioritizing this by implementing the technology and practices that reduce the impact and enhance the energy efficiency, which, as I mentioned, include the renewable energy sources, optimal energy consumption through the smart grids, through the sustainable and eco-friendly transportation options, and adopting the sustainable waste management systems allows them to contribute to reducing carbon emissions, improving air quality, and efficient resources usage. So to ensure ultimately a greener and more livable environment. And lastly, but not the least important, the citizen engagement and participatory approaches. A crucial aspect of smart cities, as mentioned already a couple of times now, it aims at involving the residents in the decision-making processes and foster this sense of ownership and participation. So either through digital platforms, mobile applications, online portals, citizens can provide feedback, they can contribute with ideas, they can participate in the budget decisions and collaborate efficiently with city authorities, helping them solve the challenges that affect their day-to-day. And the idea is to actively engage them in shaping these communities, crowdsourcing ideas for urban planning, involving them in co-creating the public services, so involving actually the community, either with energy production and sharing, or actually sharing assets and other equipment for the shared economy, and ultimately to engage and to enhance the transparency, the trust, and inclusivity in urban governance, which for the sustainability side of things needs to be a must in order to work. So these components help cities to become more sustainable, and a couple of them are through the sustainable urban mobility plans. But the main goals are always to improve the overall quality of life for residents, addressing the major challenges faced, so congestion, pollution, road accidents, the climate change conditions, while integrating the new and shared mobility services. So cities need, when they are considered smart, they do not do things like in the old way, in the old days, right? So they need to not reinvent the wheel, but actually think outside of the box and innovate their processes and innovate the way of how to do things in order to become smarter and solve the challenges that they know the community is facing. And the major outcomes that can come from these initiatives are to encourage the shared economy and other sustainable behaviors. So reducing the consumption of resources and reducing the impact of these consumptions. So reducing the emissions and concentration of greenhouse gases from the industry, from the transportation, from the different value chains that power and enable a city. Ultimately, we need to safeguard the quality, the safety, and accessibility of public spaces. So involving and renovating and making sure that these spaces are safe for people to walk and cycle and grow, and that they are resilient to the changes that we might and will face in the upcoming years, either through pandemics, climate change, or any other hazard that might happen. So all of this is part of the smart city strategy and roadmap. And in order to make it a reality, there are a couple of technological enablers for them. So one of them is the Internet of Things, which refers to the network of different interconnected devices with sensors and actuators that collect and exchange data in an efficient way. So it plays a crucial role in connecting different physical assets and the infrastructure available, such as streetlight poles, waste management systems and containers, the transportation systems, either public or shared, and the utilities, already mentioned a lot from Mágui and Hélio as well, the Smart 5 Grid and the different initiatives for smart energy. So IoT enables this real-time monitoring and data collection. It automates a few processes. It allows cities to optimize the allocation of resources. It improves the operational efficiency and enhances the services. So for example, you can have smart sensors detecting the environmental parameters, either for weather condition, air quality, the noise. They can monitor the traffic flow, count cars, count the number of people moving around, or the level of waste in different waste containers. And this enables proactive decision-making and responsive action. So as far as you understand how things are evolving and monitored, you can improve as a city authority, as a community, you can understand the impact of the different actions from the day-to-day and how it affects the rest of the community. And in order to do that correlation, you need to have a data analytics capability in the smart city solution. This might involve big data or artificial intelligence or both, or even more pragmatic approaches using simpler technology with smaller data sets, depending on the technology readiness level of the city. But in short, it involves processing and analyzing large volumes of diverse data collected from various sources. In smart cities, for instance, the big data analytics can extract valuable insights like patterns, trends from data generated by IoT devices, but also from social media when available, from other sources that might be available there, where the community can contribute with feedback or where data can be digitalized in an efficient way. And this can then make data-driven decisions. So identifying emerging patterns, predicting future trends, optimizing the resource allocation for the short term and for the medium term, so that you can actually analyze the traffic patterns and help optimize the transportation routes, reduce the congestion and when planning a big event in the city, or even improving urban mobility in general for the commuters, for the visitors that you know that use it every day or every time of the year, as you know in your community. AI, on the other hand, enables systems to learn from the data and even make predictions based on historical data. They can automate some processes, always with the human intervention, but in any case, automating a few tasks, and even interact with us in a more intelligent and human-like manner, as we now see more and more with ChatGPT and other systems where you can interact with an automated device, which is not human, but sounds like one talking to you, because even as a human, he makes mistakes and is quite biased sometimes. So there is a lot of work being done there, but these AI-powered algorithms can analyze vast amounts of data to identify these patterns, detect anomalies, and optimize different aspects of city operations. It can optimize the energy consumption, analyzing the patterns of a smart grid. It can automate traffic management by looking into congestions and the traffic light signals. It can enhance the public safety by detecting occurrences, illegal parking, suspicious behavior, and even personalized services based on individual preferences. But all of this needs to be done in an ethical way with proper unbiased data and proper training and validation by different stakeholders. Blockchain and distributed ledger technology offer a secure and transparent way to store and share data in a decentralized manner. This is a distributed database which provides a tamper-proof and verifiable record of transactions and data exchanges. So in smart cities, it can be used for different purposes, like secure data sharing between stakeholders, establishing trust in a peer-to-peer transaction like energy trading, or ensure the integrity of critical infrastructure systems. And finally, 5G networks as the next generation of wireless communication technology. It can offer ultra-fast speeds, low latency, massive device connectivity. So actually enabling high bandwidth applications, real-time data transmission, and support for a vast number of IoT devices. 5G networks in smart cities provide the foundation for seamless connectivity, enable a faster and more reliable communication between devices, sensors, and infrastructure, and enables real-time data processing, supporting high bandwidth applications like the autonomous vehicles and the development of innovative smart city solutions. And is part of the European Commission strategy for connected and cooperative autonomous mobility. So by providing this shared infrastructure, reliable infrastructure, novel services, we can pave the way for automated driving, which harnesses the benefits of automation, connectivity, and smart mobility services, and not only automate some tasks that take time from humans, where when facing traffic congestions as a driver, we waste time inside the car. So if we can reduce these cars, if we can reduce the time, or at least share the time spent in the car by doing different things, we can improve the efficiency of operations and even have a way to reduce fuel consumption, because autonomous vehicles do not need to park where you need to go. It can leave you there and take its way to a parking space, or even autonomously go through a different route, which reduces also the human factor of 90% of fatal crashes being caused by humans. So it helps in a way to benefit the road transport in Europe and overall our day-to-day. But it's not only for autonomous vehicles. So there are a couple of examples of smart cities, not a couple, a lot of them actually. I encourage you to visit, if you can, the Smart City Expo World Congress, because you'll be seeing a couple of examples from different industry players and academia, but you'll see also governments, city authorities, regions, smart islands, and even smart countries showcasing what they are doing in digitalization. So I don't want to take too much time, but a couple of cities that are valid use case studies are, for instance, Barcelona, which is actually the city who hosts the Smart City Expo World Congress every year. And they basically follow a citizen-centric approach in placing the needs and well-being of their residents at the forefront, because the city aims to enhance the quality of life, leveraging this technology and data-driven strategies. They've implemented a smart grid infrastructure to optimize the energy distribution and consumption. They promote energy efficiency through smart street lighting, intelligent building management systems, and other renewable energy integration. They have been focusing on smart mobility and sustainable mobility solutions, encouraging the public transportation, cycling, pedestrian-friendly initiatives, and even implemented smart parking systems, EV charging infrastructure, and ITS to reduce the congestion and improve its efficiency. There's a lot of open data and digital services, so they have embraced the open data policies for quite a while now, and they make a wealth of this information available to the public and encourage the development of innovative digital services. One of the solutions we showcase in Barcelona every year actually leverages a lot of this open data, so it's actually useful for us to showcase the capabilities. And for them, it promotes the transparency, it empowers citizens, and enables the co-creation of these new solutions. And there are other things. There are smart city districts, there are actively citizen engagement and participation through platforms, solutions like the Decidim in Barcelona, where residents can participate in decision-making processes and collect feedback, but also on the urban resilience and sustainability, implementing initiatives for climate adaptation, water management, and reducing waste. And this goes from the construction to the waste management and the public spaces management. Another example, also in Europe, is Amsterdam, widely recognized as a leading smart city, even in the Smart Cities for Dummies book, which has implemented numerous initiatives to improve sustainability, livability, and innovation within the city. Some of the key highlights are an integrated smart city approach. So they focus on the collaboration between the government, the businesses, the knowledge institution, and the citizens, which ensures a holistic and inclusive development of the smart city initiatives. The program acts like a platform for collaboration, bringing together the different stakeholders to co-create and implement the innovative solutions. And as one of the examples in Europe, Amsterdam aims to become carbon neutral by 2050. It has already implemented a couple of initiatives for this energy transition, like the district level smart grids, the energy efficient buildings, and the renewable energy generation. And the Smart Energy Collective project allows the residents to generate and share renewable energy with their community, promoting this local energy production and consumption. So it's a case study that's interesting to follow and see what worked and what did not work when replicating to other cities. And as you can see in the picture, I believe the only congestion caused there is mostly on bicycle usage. So the city really prioritized sustainable mobility solutions, encouraging cycling, walking, and public transportation. It implemented intelligent traffic management systems and real-time public transportation information, as well as infrastructure for electrical vehicles. So these initiatives, like Amsterdam Smart Mobility Program, focus on improving the traffic flow, reducing the congestion, promoting innovative mobility solutions like car sharing and electric mobility hubs. Because in a way, Amsterdam is committed to fostering this circular economy, not just with the transportation, but actually with reducing waste, promoting recycling, and encouraging this resource efficiency. So there is actually as well a circular innovation program, which supports innovative projects in waste management, sustainable construction, and circular procurement. And other things happening there, because there are a lot, and we don't have the time to go through it, but I am actually very a big fan of what Amsterdam is doing. There is a lot of citizen engagement and living labs. So the city involves the citizens in these initiatives through living labs and participatory approaches. The City Then project provides a test bed for experimenting with innovative solutions in real world settings. So like a test bed, like a playground to experiment with things. And citizens are often engaged through digital platforms, hackathons, and co-creation programs, where they can contribute with ideas, feedback, and other participation, other processes. And of course, this relies on robust digital infrastructure with high-speed internet connectivity and open data platforms to support the development of digital services. Lastly, we have Singapore, which is smart nation or smart island, or not smart nation, I believe, and it has invested heavily in building robust digital infrastructure and high-speed connectivity as well. It boasts extensive optical fiber networks, widespread Wi-Fi coverage, and IoT sensors, which integrate with various systems, which enable this data exchange and communication very seamlessly. The intelligent transportation systems implemented there tackle the traffic congestion and enhancing the mobility, which includes an electronic road pricing system, real-time traffic monitoring, smart parking, and efficient public transportation systems using mass rapid transit and bus services. It also prioritizes efficient and citizen-centric governance through the use of digital technology. So they have a smart nation sensor platform, which collects and analyzes data to improve the urban planning, public safety, and resource allocation. The government actually provides a range of digital services for e-payments, e-government portals, and online citizen engagement platforms, which involves, again, the community in the digital way and making the resources more efficient. These sustainable and green initiatives have been facing a strong emphasis by Singapore. They have smart solutions for energy management, water conservation, waste management, and green building practices. So the city is actually known for the vertical gardens, which I don't know if it can be seen from this picture or not, but if you search for it, you'll see a lot of examples there. And indeed, this is powered by the capability of planning ahead using the data analytics and the vast amount of data that they have been collecting and processing from the last couple of years to enhance their operational efficiency and city planning. And once again, they do have a platform for citizen engagement and participation. So they seek for input of the citizens to involve them in the decision-making processes. They have a platform called RIOT-ES, which enables the community to contribute with ideas, feedback, and shaping the policies and projects, which also promotes digital literacy and inclusivity to ensure broad access to smart city benefits for the community. And all of this seems quite easy, right? So 3 examples, a lot of successes and a lot of things done. But indeed, there are a lot of challenges and considerations when implementing smart cities. On the one hand, if we are talking about collecting and analyzing vast amounts of data, this raises concerns about privacy and data security. So it's crucial that robust data protection measures are implemented, protocols are encrypted, and the data sharing frameworks are secure so that sensitive information can be safeguarded and we can maintain the public trust. In order for these things to exchange data amongst each other and indeed leveraging on the various systems, technologies, and stakeholders, we need to ensure interoperability and standardization among different devices, platforms, and data formats so that there's this seamless integration and collaboration. There are common standards and protocols to facilitate data exchange, interoperability of systems, and even the scalability of smart city solutions, from open protocols, open standards, up to reference architectures. The focus on community is to not only, but especially to address the digital divide, to ensure that all citizens have equitable access to technology and digital services. We need to bridge the gap in digital literacy and infrastructure disparities in order to promote inclusivity. So the efforts to be made need to provide affordable connectivity, digital skills training, and accessible services to all segments of the population. And in order to make it work, so the third part of sustainability, the economic one, we need to implement, in order to implement these initiatives, it requires substantial investments in infrastructure, technology, and the ongoing maintenance. So identifying sustainable funding models, including public-private partnerships, grants, and other financing mechanisms is critical to ensure the long-term viability and successful implementation of smart city projects. So in order to make it work, it needs to leverage on collaboration and stakeholder engagement. So involving multiple stakeholders from the government to private sector, community organizations, and the citizens, so that it also involves the whole value chain. And in order not to end up with biased solutions or unfair ones, ethical and social considerations must be taken into account so that we prevent unintended consequences and ensure equitable outcomes. So safeguarding against algorithmic biases, meaning that the algorithms or the data is not only for a segment of the population or the period of time, so it needs to cover the whole social impact. And we need to address the digital rights, protecting the vulnerable population, and consider the social impact of the technological intervention. And ultimately, it needs to be for the long-term sustainability and scalability in mind. So considering the future needs, technological advancements, and evolving urban challenges are essential to build these flexible and adaptable systems to evolve over time. And thinking about the future, there are a couple of emerging technologies coming up. Some of them are autonomous vehicles and intelligent transportation systems. So the future of transportation in smart cities will involve eventually the widespread adoption of autonomous vehicles. These offer the potential for safer, more efficient, and environmentally friendly transportation. And it leverages on real-time traffic management, the adaptive traffic lights to prioritize certain vehicles, and connected vehicles as well to optimize the traffic flow and enhance the mobility. A few use cases to enhance the way of people interacting with the urban environment can use augmented reality, where you put digital assets on top of what the camera gets, or the virtual reality, where it embeds you in a virtual way. So this can enhance the navigation for community. This can provide contextual information for citizens and provide immersive experiences. You can think of virtual tours, simulations, remote collaboration, and even revolutionizing or revisiting the way we used to in order to protect cultural heritage, in order to protect it and not have crowded tours taking their car into a single place, and even doing a revolution on this urban planning and tourism initiatives. There is a play or there is a role actually for various automation initiatives in smart cities. So the community sees that robots can be employed for tasks like waste management, ensuring public safety, handling delivery services, and performing maintenance operations. So the automation technologies can streamline this process, enhance the efficiency, and reduce the human labor in areas like manufacturing, utilities, and building operations, leaving room for more creative work as our brains seek. And we see now other three opportunities, such as the sustainable infrastructure, where we incorporate renewable energy sources, green buildings, eco-friendly design practices, always aimed at integrating energy efficient technologies like smart lighting systems and energy management solutions to further contribute to reduce the carbon emissions and promote sustainable development. As already mentioned, critically using smart grids and advanced energy storage systems so that we can optimize the distribution of energy in cities. And finally, the urban farming and food security. One of the challenges cities face is the population growth. So food security, urban farming, and vertical agriculture are emerging trends. So there are innovative techniques and like vertical farming, I believe I mentioned, rooftop gardens, and other things which I'm not so comfortable about because I didn't study biology, which can produce food locally in a smart and sustainable way. And the IoT and the sensor equipment here can monitor and do precise monitoring and automate a couple of things so that we can optimize the resources production and do it in a sustainable way. And all of these future works and emerging technology have the potential to reshape and enhance smart city development. So these technologies can maximize the benefits of the outcomes and address the future urban challenges. And in conclusion, this has been a transformative approach to urban development, as you might have understood, from the power of technology, data, and innovation to create more sustainable, efficient, and livable cities. If we integrate the key concepts like the infrastructure and connectivity, the data-driven governance, the sustainability and energy efficiency, and the citizen engagement, smart cities can address the pressing challenges and improve the quality of life for residents. These present a couple of challenges in consideration, as I mentioned, but looking into the future, they will continue to evolve. So smart cities should embrace emerging technologies like autonomous vehicles, the AR, sustainable infrastructure, and so on. because they have immense potential to shape the cities of tomorrow, improving the mobility, the efficiency, sustainability, and quality of life. As we move forward, it is crucial, and I cannot reinforce this more, for cities to prioritize citizen engagement. The collaboration needs to be fostered between the different stakeholders, and the sustainable funding models need to ensure that these implementations are successful and long-term sustainable, so that they are not just done for the sake of promotion and actually have an impact and outcome on the community who faces challenges every day. So in short, it's a journey, an ongoing journey and a collaborative effort that requires the collective commitment of governments, businesses, knowledge institutions, and citizens. And by embracing the principles of smart city development and harnessing the benefits and power of technology, we can create cities that are more connected, sustainable, inclusive, and resilient for generations to come. And we are here for the long run, so let's go further. Thank you so much for listening and not falling asleep. And if you would like to follow up on more information on this, I'm happy to answer some questions. If they do not come up today, here's my email. Feel free to reach out on LinkedIn as well. Thanks so much. My name is Ricardo Petrin, and Anna, back to you.
Thank you, Ricardo, for such a comprehensive and complete presentation. I had some questions. I think you covered everything that I had planned to ask, but I'm going to ask you to summarize some key points just to make sure that everything stays in everyone's attention. So you mentioned several challenges that cities face nowadays in order to become smarter. So if you can choose the most challenging ones, which would those be?
Okay, if I can summarize and try not to repeat myself, I believe that the most pressing challenges are the rapid urbanization. So cities have been experiencing unprecedented population growth. This has led to increased strain on infrastructure. And I recall from Hélio stating before that aging infrastructure is actually a key challenge that requires maintenance and upgrades. And in fact, the smart technologies can help address this challenge of urbanization by optimizing the urban planning, transportation system, and resource management in order to help solving the aging infrastructure, but actually having an impact on environmental sustainability and public safety. Because cities with this growing population contribute significantly to carbon emissions, pollution, and resource depletion. And the smart technologies can enable them to adopt sustainable practices like energy efficient buildings, the smart grids, and sustainable transportation options like electrical vehicles and bike sharing solutions, and in ensuring the public safety with situational awareness, crime prevention, and emergency management to ensure that the growth of population does not impose a risk for them in terms of safety, accessibility, and security.
Thank you. And you showed a very complete timeline of the evolution of smart cities since the concept first appeared until today, and even what is expected for the future. But considering all the technologies that are now evolving, what do you think will be the most interesting technologies available in the near future for this evolution of the topic?
Well, I started the keynote stating that there's not one solution fits all, right? So you will see, I expect, different cities approaching different solutions or different technologies to solve common challenges. Water is a finite resource. The food resources are also limited, and the different adaptation for climate change will affect this food production and the quality of life of the communities. So there are different approaches to tackle these challenges and try to reduce the environmental impact of the ever-growing growth of population. Sorry for being redundant, but I believe that for the next decade, we will see this greater emphasis on sustainability. So even putting more and more focus on sustainability for environment, society, and economic. So we'll be able to see more and more renewable energy generation and storage, circular economy practices, and the adaptation to climate change. And I believe that the emerging technologies based on 5G networks, artificial intelligence, even blockchain and distributed computing through edge computing will help on understanding these different patterns and preventing greater risks for the community. So we will see more and more advanced data analytics and real-time decision making and seamless connectivity to have a better and more resilient decision to protect the community and plan ahead for the years to come. So the more data we can collect in a more efficient way, the more patterns and trends we can get out of it, and we can then get insights for the future to even simulate different scenarios and try to see the impact and see what could be the best approach. But again, in order for this to work, cities need to think besides its boundaries, right? So they need to share with others with what has worked, what has not, what they done, and it's really, really important that we do not reinvent the wheel or go through the same problems everywhere. So if we see cities with similar climate conditions and facing similar challenges, and if they can share what has been working with them or not, that's a good practice. So I see that the initiatives from the European Commission on creating this public-private partnerships, this association of smart cities, these events where they can come together at the same table and share what they are doing and not just promote what they have accomplished, are a must for it. So let's pay attention to what these are sharing in the next coming weeks, months, and years, and see if these trends are actually validated and being met by them.
Thank you, Ricardo, so much for your presentation and the answer to these questions. So I think that with this first introduction, we can now move forward to the presentations of some of our projects in this field. So I invite Beatriz Barateiro to share her screen. Can you hear me, Beatriz?
Yes, I can. Hi, good morning.
Hi, good morning. If you can share your camera as well.
I am not able to. I think you have to do it, please. But I will share the screen.
Okay. Okay. Can you try now, please?
Yes. Okay.
Okay,
it's
perfect.
working.
Thank you. Yes.
Go.
You just need to
confirm if you see my screen.
Yes. Go ahead. Thank you.
So I'm Beatriz Barateiro. I'm from Ubiwhere, and I will present to you one of our smart cities projects, POCITYF. POCITYF stands for Positive Energy City Transformation Framework. Therefore, you can see that the main goal is to create innovative solutions regarding energy transition for smart cities. So this is a funded R&I project. It mobilizes 8 cities, and we aim to develop different innovative solutions for these cities to build their smart city vision while taking care of their cultural heritage. So in POCITYF, we will develop different solutions with the main goal of foster energy efficiency and looking forward to create positive energy districts, that is, districts that can produce more energy than they are consuming right now. So the cities involved in the project are these ones, and the focus is mainly on the lighthouse cities of Alkmaar and Évora. And Évora is the city that Ubiwhere is closely working with and where we will be deploying our solutions. The project has a lot of innovative solutions being developed and implemented. So it was divided into these 4 energy transition tracks. Each one of them focus on specific topics. And in each one of them, we are developing the different solutions. So on the first one, the focus is to positive energy buildings and districts. So different solutions here, focusing a lot of energy production and consumption. On energy transition track 2, the focus goes to the peer-to-peer energy storage and management. On ETT3, the focus is mobility and integration with smart grid. And of course, and following what Ricardo was saying, that smart cities are for citizens, we have ETT4 focusing on co-creation with citizens and bringing them into the development of the solutions for their cities. So the innovative elements that Ubiwhere is working for in Évora are distributed like this. This is a map of the city. You can see on the top right screen the city center, where we will be implementing a few of the solutions. Then on the bottom, also on the right, we have the industrial area of the city. So it will be a different scenario. Some solutions will be replicated here as well. Others are specific from this area. And then on the left side, you can see Valverde, which is a rural area of Évora, which will allow us to study the impact of the solutions in that different scenario. So Ubiwhere is developing different solutions that will be implemented here. So I will present them one by one now. We have the pay-as-you-throw solution for circular economy, to promote circular economy and recycling. So here the idea is to centralize waste containers. These will be installed in Évora in the next weeks, and the idea is that citizens have cards to open these containers, and in this way it is possible to monitor how much waste is being produced. Citizens will also have access to a mobile application, so they are informed about the amount of waste they are producing, and also the city will have a management platform to have access to the information about this sector. So this is the containers that will be installed in Évora, also the current for the citizens. This is a small pilot. We'll install 4 containers, and we aim to reach almost 100 people with this system. And the idea is to validate adherence and to start studying the impact of the solution for further in time. We fully implement the use case of pay as you throw, and have people paying exactly for the amount of waste they are producing, instead of paying it attached to the water bill, which is currently happening. So here is the administration portal for the city. They are able to manage all of the system here, the containers that they have, see if there are any alerts, also the users using the system, and all of the configurations of the hardware devices. And then they have the city portal, a more user-friendly dashboard, where they can have insights on different metrics about the utilization of the system, some statistics and data analytics about citizens using the containers, how many deposits, collections, about them using the mobile application, for example. And then the mobile application available for citizens, where they are able to see containers nearby, how many interactions they have been making, how many deposits they have been making, and be more aware of the waste they are producing, and also to report any occurrences that they find with the containers and to directly communicate them to city administratives. Moving forward for ETT3 regarding mobility, Ubiwhere is developing the EV chargers management platform, or EVCM. This also sends on the management portal. Here again, those who own EV chargers will be able to manage their assets, create or integrate more EV chargers, validate who is using the EV chargers, how many times they are using it, and so on, and also helps with maintenance of the containers. Again, it is supported also by a mobile application here for the EV drivers. They will be able to unlock the chargers with the application. They will be able to see in real time where there are available EV chargers or if they are occupied, and they will be able to schedule the charging process here. So we are compliant with international standards and communication protocols to make sure that we can integrate as much types of EV chargers as possible. And we are also communicating with an energy optimization algorithm, which will help us manage the energy used for the charging process and will optimize when the process is occurring. Also here to foster energy efficiency. Moving forward for ETT4, and we will have two different solutions. Here we have the city information platform aimed for city decision makers and for city administratives, and then the cultural experience marketplace, which targets more citizens. The city information platform provides a map view of the city with all of the assets and all of the infrastructure that is being installed in the scope of POCITYF or other infrastructure that the city is aiming to monitor. We'll be able to see here what is the status, is there any occurrence related, have a real-time view of its utilization, but also a short historical data for comparison. And the idea is to allow the city to make decisions in real time about this infrastructure. Then we have the 2D and 3D perspective, and this is extremely relevant in the scope of POCITYF since we are monitoring energy consumption and production in specific buildings, and this will be possible using this view. It is integrated with GIS tools, and in this way we will be able to see the performance in terms of energy for the buildings being monitored. Supporting this real-time view in the map, we have the analytics dashboard. This provides data with a more historical background, and you can see the performance and the impact of the solutions being implemented, what happens during the week, what happens during the month, or what happens during the year with the solutions that we are integrated in the sectors that the city is analyzing. Also here, the idea is to be able to help the city make decisions. And then the indicators, this was a lot of work with the city and the partners of the project to define the relevant KPIs to analyze here. Also complements the map view that provides the KPIs view per building. Here we will have a more holistic view about these KPIs and about the performance in terms of the whole district and see how far are we of becoming a positive energy district. Again, here we have the CIP Citizens, the platform aimed for citizens to use. They will also have the view of all of the infrastructure and services that the city has for them. They will be able to see available EV chargers, available parking spots, and so on. And they will be able also to provide feedback for the city, and to interact with all of the services provided. Then for the cultural experience marketplace, the focus here goes to events and to sustainable practices related to events. So we'll also have the view on the map where the events are happening, when they are happening, a lot of information about the cultural agents promoting these events. And then the idea is to foster sustainability associated with cultural activities. And in here, citizens will be able to evaluate the cultural agents promoting the event and see if there are sustainable behaviors, both on the side of the organization and both on the side of citizens entering the events here to promote more those who are practicing sustainable behaviors. And that is all for now. Thank you for your attention. And if you have any questions, please go ahead. Otherwise, back to you, Anna.
Thank you, Beatriz. I have one very short question. So you presented several, I would say, small solutions within the big solution that is the POCITYF project. And I wanted to understand if these solutions are scalable by themselves for other cities in the world, since you said, both you and Mágui presented 2 cities as the lighthouse and then several other cities as kind of mimicking the best practices that the lighthouse cities have. So I wanted to understand if these solutions that you presented here today are scalable for all of the other cities, and if it is something that it's easy to do.
Yes, that is the idea. Of course, each city is one city and has specific needs and well, challenges. But the idea is that the following cities are able to monitor the impact of these solutions on the lighthouse cities, and then based on their needs, they can identify the solutions that would make more sense for them, and then they would be replicated for them and integrated, scalable for those cities to also provide them with the chance of becoming smart cities with these solutions.
Thank you, Beatriz. That was my only question. Thank you so much. And I think we can now move forward to our next presentation with Beatriz Mendes. Thank you.
Hi.
Hi. Can you turn on your camera and share your screen, please? Perfect.
Okay.
Okay, thank you. Go ahead, Beatriz.
Okay. So, hello everyone. My name is Beatriz. I'm from Ubiwhere. I'm here to present POSER. Okay. So, what is SmartPage? SmartPage is a technological solution that supports municipalities in separating and collecting bio-waste, compliant with the Union European environment policies. This is a software platform that implements behavioral changes and overcome waste management challenges. So, with SmartPage, waste containers are retrofit with access control devices to track how much bio-waste is separated and offer the citizens an active part in the sustainable transformation in their own cities. This enables municipalities to digitize and to optimize the collection of bio-waste for the treatment to audit the operation performed by the waste collection companies. So, where they meet, the problem statement is: how can public authorities trust and validate the location shared by the waste collection companies if location data can be spoofed? So, POSER aims to bring a decentralized location service. It's not simply a software solution, but rather an extended to both software and hardware. The focus is really on the decentralization. We ought to take part in an already established community rather than building a brand new one. So, for this reason, POSER leveraged the Helium network. So, here you can see how the SmartPage is constructed. So, the waste collection truck kit from the SmartPage use the existing LoRa infrastructure and triangulate the algorithm to ensure that the proof location that is obtained by the hardware kit and that guarantees the greater trust between the entities involved. So here we can see what POSER does, that use the software development kit and validates the location, okay, shared by the mobile devices, and based on the network of helium hotspots, demonstrate that a dynamic proof of location is beneficial for the smart system solution as a smart plate. So this is the results of the combining the two and the demonstrations of the results. So this is the results were in our expectation, and since we were able to develop the software developing kit that validates the location based on the network Helium Spotify, we prove that this is really beneficial for the smart cities. Okay, and you have here a QR code where you can see our white paper that talks about more of this solution if you want to see it. Okay, so to conclude, combining the two solutions, we help ensuring that the bio-waste is effectively collected and in appropriate times, so in a trustworthy manner, and avoid that this deteriorates or get damaged. In that way, to retrieve some optimal results from the recycling and composing process. That is one of the things that we are trying to fight with these solutions. And I think that's it.
Thank you, Beatriz. I have a very small question. I hope it's easy. So do you think that this solution is possible to scale for different use cases beyond the paid use case?
Yes, of course, because this uses the proof of location. So we can try to put in some other use cases to see what is happening in real time.
Thank you so much, Beatriz. I think we can now once again check the white paper. So I invite everyone to check the white paper that you presented. This presentation is live, so everyone can find it, and everyone can check that one and the previous one from the first part of the project. And I think now we can move forward to our next presenter. So we will have the last presentation of the day with the project CityCatalyst with André. I think you can connect now, I hope. Just checking if everything is okay so that we can move forward. Okay, perfect, André.
Yes, sorry, I was checking my screen. I'll share the presentation now. I hope you can all see my screen now. So the CityCatalyst project, let me just find. I'll put this on. Yeah. Okay. So the CityCatalyst project is basically a mobilizer from the Portuguese PT 2020, which is the national project for cities, and it's developed or divided in different projects and services that allow us to have a clear picture of what a city is and what a city should have in terms of morphology and understanding of the necessary things that compel of a city. So it starts with the PPS one. So PPSs are the projects, processes, and services that come from the project as a whole. So basically PPS one provides the information on how to build networks and operate them. Basically, these are the networks that allow us to have the specific custom fit scenarios for networking technologies, for having 5G oriented solutions, for having the specific sensors, video analytic use cases, depending on what the city needs and what the city understands is its maturity. The PPS2 focus itself much on gathering this, or the PPS1 gathers this data, and the PPS2 focuses itself on securing these data sets and securing this communication. So basically allowing for having the TLS mechanisms and allowing for having secure ways of intercommunicating the information from the devices itself, from the gateways themselves, until the end of the platforms and the understanding of the data gathered in a single central manner. PPS3, which is the one that we will focus today, and we will focus on our Ubiwhere's efforts and our partners, CCG, and all of the other partners that have use cases that we will see in a bit. Basically, it creates the necessary data flow between these devices and provides all of the platform-oriented aspects for the project, and as a specific platform and a specific federated access platform for the project. PPS4 then gathers all of the necessary information from the different stakeholders of the city and understands with focus groups which are their necessary policies or the necessary things that the city should focus on. Is it open data? Is the data necessarily open? Should we open this kind of data sets? Should we focus ourselves on this kind of challenges or any other challenges? Should we have open calls for external developers to build upon our different solutions or not? Then PPS5 focuses itself on gathering everything from here and putting everything together on a demonstrator in a single entry point that as the city on board and tries to understand this is the city maturity, these are the city objectives, so this is what we need to do in terms of technology to overcome and to reach those objectives. PPS6 focuses itself on more of the project management aspect of everything. So for specifically on the aspect of the PPS3 and from the federation aspect and the objectives from the platform and from the development side, we aimed at integrating an harmonization of different platforms existing on the 4 different pilot cities that we will see in a bit. It's basically to get them all together on a specific data lake and a specific semantic module, an harmonized module that would facilitate the different topics of the demonstrator. This is very important because during the project, our main investigations were towards having a central entry point for data. This is a very complex thing to do because if you have different vendors of different technologies, of different sensors, you would need to have specific, and this is the objective number 2, SDKs that would convert that vendor-oriented or vendor-specific API or data model to a common aggregator platform, a common data model, and common standard or data model to communicate. In this sense, we were evaluating, or in the first steps of the project, we evaluated the aspect of having NGS-ILD oriented APIs, and then with the smart data models on the bottom that represent the information that would exist on the aggregator platform. This entails a very good way of having, and if PPS4 or PPS5 would see the need to have a different service or a third-party services running on top of the platform, being harmonized or having harmonized data would be a very easy way to just add services along the way. Then to integrate the batch and streaming data analytics from the different cities that they have. So basically understanding the maturity of the city by saying, okay, you have already these data sets, we would integrate those first, and then you have a couple of more data sets that you can integrate along the way. Then to provide an AutoML component that would serve as predictive algorithms for demonstrators. This is basically a way of gathering all of the information and then getting that information or specific information on top of prediction scenarios. So basically we would predict the traffic flow for tomorrow. We would predict the impact of different traffic flow on the different CO2 emissions or anything else. Create a central authorization on an authentication component. This is basically the heart of the federated platform and the art of the different aspect of federating the identity of the person or the people that use the platform, and then the two different modules for the SDK to integrate the new domains with the platform. This specific is for parking and waste, just examples, different aspects. We integrated energy, we've integrated traffic, we've integrated air quality and some more. Then to create, and this is the final thing, to create a tool that indicates the performance of the analytics services. So are they running well? What's their performance? What's their accuracy looking like? What did the last push of information we did that would benefit or not the model that's running? And also, what's the performance of the machines that are running this? Since this is a cloud native thing, what does the server look like? Is the server well in terms of health? Is it going to crash or not, depending on what we are doing? Basically, and this is a job that CCG, which is one of the partners of the project, led in the project. We basically have the different adapters on the bottom. So if you see here, you would have the Ubiwhere solution, which is focused on Guimarães and has the idea of having traffic and air quality together. You have the adapter from Lage, which is more correlated with crowd observations and crowd flow observed from people. Then RIOT-ES was developing something towards mobility and something towards those use cases. FSEC was running with Porto the more energy oriented scenarios and the adapter for it, and then any other that can come. So basically this is the maturity that we've found out. So basically different platforms with no correlation between them, but we wanted to understand how can we have a single entry point for all of those platforms and go towards that vision. For that, we anticipated to have a central data lake, and then a broker that would be Kafka that would then separate everything, and then an API on top to map the accesses for the services. Of course, this was very difficult because having this idea, everything together, and having everything on the same platform and the same data lake was very complex, because different information and different protection of that information is an important aspect. So what we ended up doing is separating each of the data nodes. So each of the data sits at rest in the platform, and it's the tuple between the platform and the entity, in this case the municipality that owns it, and then it just shares what's needed for what it wants for the central information platform, which is if I have analytics from the last week of air quality, I will share those because I will catalog those as public information, but I will not share the private data sets that I have that calculated that specific thing. So what you are seeing here is basically the skeleton of that system working. So basically each one of the municipalities and technological partner, then the data bus is the implementation that we are doing to get everything on the same standard, to get everything accessible from the central platform and the central way of seeing this. Then the technology environment, just to have a brief overview. So basically, I'll not get much detail on this slide, but once again, the data providers on the bottom, then it passes through. Most of them are open source technologies that we are using, that we are running on cloud-oriented infrastructures and having them accessible from the different partners. You see a lot of similar solutions for the same use cases because different platforms are using different flavors of the same technology or are using different technologies because their technological roadmaps are completely different. And that was the thing. Specifically, the Guimarães demonstrator and Ubiwhere's contributions for this demonstrator. apart from the contributions that we've done in these different architectures and having everything on the same place, of course. So the city of Guimarães wanted to have a demonstrated committed to sustainability and committed to the quality of life of the city. In this sense, we needed to monitor air quality, and we needed to monitor one of the most important producers of emissions in the city, which is the traffic. So we wanted to have specific readings from air quality and specific readings from the emissions from the cars. So we aim at using air quality stations, CCTV cameras, open data portals, and any other data sets. We gathered everything on the same platform and got everything together with the SDKs and on the data bus, or specifically on the data bus. The main goal of the platform was firstly and upfront and foremost, the most important goal was to harmonize everything on NGS ILD, because this was the framework selected by the project to be follower of. Then have the interoperable framework, have myself being able to, on the top of the services, have a service that could run, or on the top of the platform, sorry, have a service that could run with those APIs, then to create the open source SDK so other cities can follow the rules that we have. Imagine that we are doing an integration with a specific provider of air quality sensors, and CTB is also doing that, so they can just push our open source SDK to map everything to NGS ILD standards. Then the assessment of the current status of the SDGs, the 3, the 11, and 13, which are the most important for this, and then provide tooling to ingest this data, harmonize the data, feed everything onto the ML models and platforms, and then create the relevant KPIs that are on top of that. That are specifically, and this is something that's not in the presentation, but it's important to say, that are mapped to some of the ISO 37120 goals, which map themselves to the SDGs at the end of the scope. Here are the specifics. So SDG 3 is good wealth and well-being. SDG 11 is sustainable cities and communities. SDG 13 is the climate action one that we were following. This is just the skeleton of the, more or less, the flow of the data running. So we ended up having IoT-based systems and other integrations specifically for IoT, then existing apps and services on the other end, which are completely different ways of integration, then the different technologies that run on top, then the context broker that we ended up choosing, or INLD, to have everything together, the different aspects of running AutoML or not, and then the federated platforms, the web front ends, and the other APIs that run on top of this. Thank you very much for the time. I hope the presentation was clear. If there are any questions, please feel free to ask them. Thank you.
Thank you, André, for your presentation. I only want to ask a very short question. So you presented a demonstrator for the city of Guimarães. The project has several other demonstrations with other objectives or other goals. My question is, are they all in the same city? Are they in different cities? And if so, can we scale these demonstrators to other cities in the country and in other countries?
Okay, so excellent question. Thank you, Anna. So basically, the different cities have different objectives and different use cases to do. So for example, Guimarães was focused on air quality and well-being. Porto was more focused on energy. Aveiro was more focused on mobility, and then Famalicão, which is the other one, was more focused on people flowing and having the understanding of how many people are in specific spots of the city. So basically, all of them are very different. The main objective and the point of scaling, which is the one that you bring up, is so we have all of them need to be, or should be, or must be compliant with the same standard and the same APIs, so that if you want to add, for example, a parking use case for the city of X, doesn't matter which city it is, if it is compliant with smart data models and NGS ILD, it should appear on the federated platform that we have from CityCatalyst. So this is the most important thing on scaling up different cities, or on scaling up a common model, a common information model for everyone, which is if everyone speaks the same language, we will understand each other very well. And we can have even, and in terms of scaling, you can have even, or foster your community to have specific best of breed apps. For example, an app that understands the flows of parking versus the flows of traffic can be built on top of the infrastructures that we have ready on the federated platform of CityCatalyst, and can be scaled for the different domains or the different municipalities that have that vertical or that information available.
Okay, I think with this answer and intervention, we can close this session, which was very interesting today, and which focused on both smart cities and smart energy. So I want to once again thank our keynotes, Mágui and Ricardo, for helping us understand both these topics, as well as my colleagues from Ubiwhere, who came and presented some of our projects in these two topics. And lastly, but also very important, all of the colleagues of all the teams at Ubiwhere that help us make these webinars possible. So thank you, everyone. And if you have any questions regarding any of these projects, please feel free to contact us. We will be more than available to help you understand all of these topics better. Thank you, everyone. Hope to see you in the next event.
Especially Anna too. So yeah, and also all the delightful insights that we had. Thank you, everyone.
Thank you.
Our pleasure. Bye-bye.
Bye.